Okay, let's talk about power supplies. It's very important that you have not only a good, reputable power supply in your arcade machine, but one that is functioning properly. If you have one that's not functioning properly, it can send too much voltage or too little voltage to your board, damage it, cause all kinds of problems. So this was in our Joust machine at the arcade, and somebody at some point way in the past had converted it from the linear power supply to a switching power supply, which is totally fine, at least, to get the game up and running. But recently we were having issues with Joust where it was glitching out and freezing and stuff. So the first thing I did, of course, is you test the power. I noticed that the power was at the power supply was like 5.7 volts. I'm like, oh, that's no good. So I tested at the PCB and it was 4.4 volts. I'm like, what? That's odd. So we were getting 5.7 out of the power supply, but only 4.4 at the PCB. So I think this thing was failing under load. I'm not really quite sure what was going on with it. So I took this out and I put a replacement in, a brand new replacement, and everything was fine. I metered the power supply at 5 volts and we had 4.9 at the PCB, so that got the game board back up and running, and Joust is now working fine. So we have a faulty power supply. Now in the past I would just take these and throw them in the garbage and replace them with a brand new one, but there's not really any reason to. So I have to do that, I should say, because these are rebuildable. I have learned in the past that it's easier to just spend $10 and replace the caps than it is to spend $30 to buy a nice new reputable replacement power supply. Because if you replace the caps, this should be just as reliable as a new one. So we're going to do that today. We're going to take this apart and we're going to replace the caps and see if we can get it reading in a more nominal way. So first thing to do here is we will hook this up to my bench power supply for our AC input, and we'll test. Actually, let me do this first. We'll test to make sure and see what it's outputting here on the bench with no load on it. So I have this turned completely down. So if we zoom in here, we can watch this. I will turn it all the way up. Okay, that is all the way up. Now I'll turn it all the way down. That is 100% all the way down. So we should have somewhere around like 4.5 volts or so with it all the way down, but we don't. I'll show you what we have here. Okay, we'll give it some AC. Let's turn it on. And the LED is lit, so we are good to go. Now, we should have, somewhere around 4.5 volts, but on the 5 volt line we have 5.2 volts with it all the way down. If we go to the -5, we get -4.7. That's probably a bit more accurate, but the 12 volt line is 14.7 volts with it all the way down. Now, if I was to try and turn this up, now there's no load on this, so it's going to be slightly not accurate, but it shouldn't be almost 15 volts with it all the way down. If I turn this up all the way, it goes to 17 volts. All the way down is 14 volts. So that should be around like 11.5, not 14.7. And again, our 5 volts should be around 4.5 or so, not 5.2. If I turn it all the way up, it goes to 6.6 volts. So this is definitely not regulating properly. So we've got it all the way down now again, 5.2. So let's not adjust the adjustment at all. We'll leave it at 5.2 all the way down, and we will turn power off before I short something out here. And with that accomplished, let's take this apart and recap it. Shouldn't be too difficult, and we'll see what it reads afterward. So when it comes to taking this apart, it's just as easy as taking all the screws out. One, two, three, four, 5, 6, 7. Okay, these ones with the coarse thread go on the heatsink. There's only 4 of them. I'll keep those separate. If I was a smart man, I'd keep them separate. So we'll put those over there, and that's it. cover comes off. Now we just had it powered up, so it's probably a good idea to discharge it. Now, take that with a grain of salt because there is enough voltage in here to probably hurt you. So we'll discharge the filter caps and that should be safe to handle. But I can already see we got a bulging cap right here. This cap is absolutely, look at that. That cap is got a nice dome forming on it. The other one is not so bad. I don't see any other ones, but we'll change them all out. So let's go ahead and discharge this. Get this out of here. So obviously you don't want to touch anything, so let's take these two filter caps and see if we can get a nice little spark here across these. Okay, ready? Nope, nothing, and nothing. So the filter caps are discharged. Any other high voltage caps we should worry about? Nah. We can try this one. Nope, that one's discharged. And this one that's bulging, that one's discharged. So safe to handle. Filter caps are discharged. Other high voltage caps, these are actually only 16 volts, so those aren't high voltage, but the filter caps are discharged, the bigger caps are discharged. There's nothing else really to hold a charge that could hurt us, so that should be fine. So take that with a grain of salt. High voltage inside of here, so be careful. Don't go poking around if you don't know what you're doing. So that's kind of why I'm making this video, to show you what to do. And now that we've discharged our filter caps and the other bigger caps, should be good to go. So that being said, I need to go through here and get a list of the caps to see what this needs. I'll make a list, I'll grab the caps, I'll come right back, and we'll get to changing them out. Well, scratch that. I don't have any of these caps. I don't have the 200 volt. The filter caps are 200 volt 220 microfarad. I don't have those. This cap here that's bulging is a 16 volt 3300 microfarad. I definitely don't have any of those. So what we're going to do is, because this one is bulging, we're just going to replace this one and see if that fixes the problem, because I had to order 2 cap kits, one as a spare for in the future, and some filter caps. So it's going to be a couple of days before those arrive, but we don't really need to recap the entire thing. We only really need to recap the caps that are bad, or replace the caps that are bad. So we're going to change this one here that's visibly bulging, and then see if it's back to running normally. If it is, we'll call it repaired, and then I'll just cap it and reflow it and get everything done later and add it back to as a spare replacement for the arcade. But for the purposes of the video, because I don't have the right caps, we're going to use a Frankenstein type of deal here in order to get up to 3300 microfarad, and then we can test it and see if it's back to working order, because it's likely the only fault in this is just this one bad capacitor. And we're going to use the meter to test it afterwards. So sometimes you can test these in circuit. So if you've got a nice fluke like this, you put it in the diode checker mode, and then you hit the yellow button to change it to capacitance. So this little symbol here is capacitance. If we hit the yellow button, now we're on capacitance. You can see the little UF right there. So if we were to, for instance, now it's nanofarad because I touched the leads, but if we go to that, let's just go to the filter caps. So the filter caps are 200 volt 220 microfarad. So if we go to those, we should get a reading of 220 UF, 225 UF. So that filter cap is good. This filter cap should be 220 UF also. 230, 232, 230, 229. So our filter caps are good. So let's go to this capacitor here that's, oh, well, this one's bulging. They're both bulging. This one is slightly less. Okay, so those are definitely bad. Even this one is bulging. All 3 of these are bad caps. I don't know if you can tell, but that one is slightly bulging. That one is slightly bulging. That one is slightly bulging compared to this one here that's not. So you can see that we have, so, well, just for visual testing here, let's go to those pads, and it looks like it's these 2 joints here should be 3300 microfarad, and we get no reading at all. What about the other one? No reading at all. That's why sometimes you got to take these out of circuit. So let's just take these mamma jammas out of here. Okay, so there's one. It doesn't show signs of leakage, not at all. But if we take it and set it flat on the surface here, you can see that weebles wobble, but they don't fall down. So there's evidence right there. That one's bulging. That's the one that was the worst of the two. But if we test it now, we'll put negative on negative, positive on positive out of circuit, we get, well, we get 2800 UF. Should be 3300. So 20, see, it's going down. 2600 UF. So it looks like we're at 2500 microfarad, and as you can see, it's supposed to be 3300. So that cap is bad. Let's remove this one. Okay. No signs of leakage on this one either, but weebles wobble, but they don't fall down. So there's two bad ones. Let's see what this one reads. 3300 microfarad. Oh, that's even worse. Look at that. 1600. That's half. Oh my Lord, that's going down. Well, no wonder our voltage is wrong. We're at 1100 microfarad. So we're about, we're 2200 microfarad low on this one. So, and falling. So we've got, there's two confirmed bad caps. Let's go with this other orange one here. No signs of leakage on this one either, or on the board. And this one is 16 volt 1000. I have plenty of those, so we can replace that one easily. And oh, look at that, 1500. Should be 1000. So, and then does this one wobble as well? A little bit. So there's three bad caps. The rest of these don't look bad. This one here is 25 volt 1000. Let's see what that one reads in circuit here. That's why you got to read them out of circuit, because I just got a reading of 8,000. It's supposed to be 1,000, but I don't see it visibly bulging. So those three caps were the only three I saw that were visibly bad. So we're just going to change those three and see if it reads. Because I mean, obviously, when the correct cap kit comes in, I'll change all the caps, do the reflow and all that. But for education purposes here, I just wanted to kind of show what to do and how to test these caps like this, because it is possible to resurrect these power supplies for, you know, pennies on the dollar compared to buying a brand new one. So now you wouldn't have to replace all you don't have to change out the caps just for changing the caps out sake. You know, if all the caps read good or within tolerance, you really only need to replace the caps that need replacing. You know, but this is replacing all the caps is one of those while you're in there type of things. You don't necessarily have to replace all the caps, just the ones that check bad. Okay, what do we have? The 16 volt 1000. Let's put a 25 volt 1000 in there. That won't hurt anything. I got a 25 volt 1000 right here, so we'll use that. Okay. That was this position here. Okay. We'll get one leg in here, and then we'll push down on it. There we go. Get the other one. Clip the legs off, and now we're going to have fun trying to get these replaced. So these are supposed to be 3300. So I'm gonna put a couple of 2200s in here. 16 volt, I have 35 volts. So put some 35 volt 2200s in place of the 16 volt 3300s. And I'll show you a little magic trick here. If you put capacitors in parallel, you can build up the reading. So we can get to 3300 by adding a 1000 and 100. Now we're just going to solder them to the bottom of the board and then leave it, sitting like this, and we'll take our measurements like that. So I also want to show you here that if you are suspecting that a capacitor could be bad, even brand new, you can test them the same way. Just put your meter on the diode checker and then press the button to go to capacitance, and we'll test this. Should be 2200, and we get 2184. So good. So let's put this other one in here. And when my correct capacitors arrive, I will just go ahead and take these back out and add them back to my inventory. So no harm, no foul. But to get the video out there, it's not necessary to recap the whole thing. It's just as long as the information is out there and correct, that's all that's important. So, all right. So now we need to add this. We'll add a 50 volt 1000, and negative is this leg here. So if we were to do this and this, now we have 3200. Then we can take our 100. Okay. And do the same thing. Negative on this leg. Positive on this leg. Might have to do some interesting solder work here. There we go. And make sure we're not touching anything else. Nope, that's good. So we should have close to 3300 on here now. So again, with this being in circuit, it could throw the readings off, but if I go to the two pads, what do we have? Yeah, I'm not sure if it'll read in circuit. We'll do the test here out of circuit, just for showing, yeah, it won't read in circuit, because there's too much other stuff on the circuit for it to get a reading. So there's our 3300 for this cap. Now we gotta do the same thing again. I gotta grab another 100 here, because I didn't know the other cap was bad. Okay, there we go. And okay, so just so you can witness here, how am I going to do this? We're going to solder all these together here. So we can do a little show and tell, negative to negative. Positive to positive. Okay. Now we'll go up a little higher here for our 100. Oh, I gotta get more length on my solder wire here. All right, so now we have negative on, oh, hang on. Okay, there's a negative on that. And Yeah, I realize this is not ideal, but just as a science experiment here to show you what happens. There we go. Okay, so we have a little, amalgamation here of there you go, of 3,300 microfarads. So if we were to, so these are all in parallel, negative, 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 positive, 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 all connected together. So if we were to go across negative and positive, it should be 3,300. And we get, come on. That's not right. There we go. 3,370. Bada bing. So there you go. If you need to do some type of crazy science experiment to get your correct capacitance, you can put some other caps in series to add to the value, and there you go. So let's see. I got to make sure negative is on this side here on the right, so we need to figure out how we're going to do this. I may have to simply undo. No, we should be able to just go like this. Hopefully we should be able to just do, no, that one did not cooperate. There we go. And this is going to be the fun one here. Might be able to get away with it. Yep, I think we did. All right. Look at this. This is crazy, but I promise it'll work. Okay. So negative is this way, which is this way, which that's all correct. Positive is correct. Those... Wait a minute. I almost goofed up big time. You were watching, and you knew that I was about to goof up big time, but you didn't say anything. You sat there and watched as I almost goofed up big time. You guys, I thought you were there for me, but apparently not. That's okay. I'll forgive you. All right, let's try this again. I almost put an extra 2200 in there that shouldn't have been in there. How many of you guys were screaming at the screen? All right, so now we are good to go. So what do you think is going to happen? Is this going to work? Of course, with this sitting like this, we're going to power this up the way that you see it. And of course, you want to be careful and not touch anything while it's powered up in this state. But this should give us our correct readings now, hypothetically. Okay, I'm going to turn this on. Hopefully nothing goes poof. Let's find out. 1, 2, 3. I'm shielding myself, everything, no smoke, no bulging, nothing exploding so far. LED is lit. So we'll go to ground, which is this leg here, and we're still turned all the way down. So let's see what 5 volts reads now. That's more like what I'd expect to see, 4.6. Hang on. Let's swap these around. 4.6. How about that? -5, I believe, is here. Nope, that's 12 volts, 11.3. That's exactly what I thought it was going to be last time. -5 is here. -3.8. So there you go, bad caps, as exactly as you'd expect. There you go. So we have a functional power supply now, but I can't leave it like this. But just for the purposes of the video, like I say, you really don't even need to, I don't need to change the rest of them because it's working the way it's supposed to now. But I'm going to go ahead and change them all out since I ordered the caps anyway. But, you know, there you go. If we adjust our voltage to read properly, we can go ground and 5 volts. And I don't want to, gotta be careful here, I don't want to short anything out. And if we adjust our pot here, 5, we'll put 5.1, and then by the time you hook up a PCB for a load on it, you get down to 5. So Perfect. 5 volts is good now. -5 is -4.3. That's not too crucial. 12 volts is 12.4. Outstanding. So there you have it, a successful power supply repair. 3 bad caps were the problem, and like I say, technically I don't got to change the rest, but I will. So I'm going to get my Frankenstein stuff off of here and wait for the cap kit to arrive, cap it, reflow it, and add it back to the inventory, and there you go. So a little edification. I tried to combine those words there and I messed it up. So a little edification/education for you. If you weren't aware, you can rebuild the power supplies. 99% of the time it's just bad caps if it's not putting out the right voltage. Case in point. So thanks very much. Like I say every time, I appreciate it. Like, share, and subscribe, and we'll see you next time.